So this lesson is very much about setting up for the last type of volume we're going to work with. So this lesson is going to have basically no calculus in it at all. This is basically a geometry and algebra skills thing, and I'm going to try and keep it real quick. This is just about writing expressions for the areas of geometric figures. So I'm just going to get going. I want us to find or write down the equation for the area of each of the following geometric figures. So the first one is very, very simple. If you had a square that had side length x, so in other words, if you're looking at a square and you know that one of the sides has length x, what is the expression for the area of that square? Well, it should be rather simple. If it's a square, then the other side is also x, and that means that the area of that square will be x squared. Yay. Very simple, right? And again, for the next several examples, that's all I'm asking for us to do. All I want us to do is come up with an expression for what the area of the thing is, right? So if you feel like these are easy and you can do them on your own, you might check out these. I'm going to go through them one at a time. So an isosceles triangle with a leg length of x. So isosceles triangle, I just realized I need to say that this is an isosceles right triangle. So an isosceles right triangle with a leg length of x. So if this is x, well, great. It means this is also x. And the area of this thing would be 1/2 base times height. So that means 1/2 base times height, so 1/2 x squared. Okay. Next up, the equation for a semicircle with a diameter of x. So semicircle means you're looking at half of a circle, and you know that the diameter of this thing is x. Right? Well, we know the area for a semicircle in general should be 1/2 pi r squared. So the only real question is, what is the radius in this case? Well, the radius is half of this, which means it's 1/2 x. So if I plug that 1/2 x in here, I'll end up with 1/2 pi times 1/2 x squared. If I simplify that, I'm basically going to end up with 1/8 pi, 1/8 pi x squared. And that's our equation for a semicircle if its diameter is x. Okay, a quarter circle with radius x, okay, that just means you've got a quarter circle. The radius of the thing is x. So similar to what we said on the previous one, we know that a quarter circle should be 1/4 pi r squared. In this case, our radius is x, so if we plug in x, we get 1/4 pi x squared. Okay. I've just got one more little one of these, and then we'll get into some sort of real examples of this stuff. The last one is an equilateral triangle that has a side length of x. This one's a little bit harder to see, and to be honest, these problems are pretty rare on the AP exam, but I feel like it's something we might as well know about. If you have an equilateral triangle, it means this entire side is of length x. And this is a 60-degree angle. So what we can do, and this is, I'm sort of going to derive this for you, you can come up with a little 30, 60, 90 triangle here. This ends up being x over 2. This is x, and this is x root 3 over 2. And so the area of the entire thing will end up being 1/2 of the base, which is x, times the height, which is this thing that we just found out, x root 3 over 2. And so the formula we end up with is the idea that it's root 3 over 4 x squared. You may have seen that formula before. Like I said, this is a really rare one. It's unlikely that I'm going to test on it. It might show up on the AP exam. I'm not going to make a big deal about it. I have 3 more serious examples of these, and I'm going to go to them next. And what I mean by more serious is, by the end of this lesson, we need to be able to do all of these things with expressions that aren't just x. So let me get into the first example. I want us to write an expression for the area of a square that has a side length of sine x plus 2. So all that means is, if you had a square, and the side of that square was sine x plus 2, area for that square, well, I mean, it's a square. That means the other side is exactly the same. So the area of that square would be sine x plus 2 squared. Not a big deal. This is a very, very basic skill, but it's absolutely necessary for the problems that we're going to get to by the end of this lesson. I've got 2 more examples, and I'm hoping you can do those on your own. So next, I want us to write an expression for the area of a semicircle with a diameter of that. So in this case, I'm going to sort of set up the picture for you. You've got a semicircle. You know that the diameter of the whole thing is 6 minus x squared. And what I want is I want an expression in terms of x for the area of this semicircle. And I'm going to tell you now, it's not going to be pretty, but take a minute and try and work that out on your own, and then we'll go through it together. So we know that the area of a semicircle is supposed to be 1/2 pi r squared. So what I need is I need to know what the radius of this circle is. Well, the radius is going to be half of this expression that we have. So I'm looking at 1/2 pi times 1/2 of 6 minus x squared. Note that squared is going to apply to both the 1/2 and to all of this. So what we're going to end up with is 1/2 pi times the 1/4 times 6 minus x squared. So I basically end up with pi over 8 times 6 minus x squared. This is our expression for the area of this semicircle. Again, it's not pretty, but it gets us the area, and by the end of this series of lessons today, you'll be able to do some things with that. One more example. The last one, write an expression for the area of a quarter circle that has a radius of 3 minus x cubed. So I'd recommend you pause the video, draw a picture of a quarter circle, draw that radius on it, and then write an expression for the area of that quarter circle. So your quarter circle should look something like this. If you decided to draw yours some other way, that's fine, as long as you label the radius as one of these things and not this, because that's not a radius. We know the area of a quarter circle is supposed to be 1/4 pi r squared, because it's a quarter of a circle. And in this case, they gave us the radius. The previous one was slightly harder because they gave us a diameter, but in this case, we have a radius, so we just plug that in. This is 1/4 pi times 3 minus x cubed squared. Yay. We could expand this, we could FOIL that out, but I'm not asking for it now, I just want an expression. That's the end of this first video. In the next one, we're going to work on one other basic skill, I think, and then move on into some calculus. So I'll see you there.